The first part of this tutorial was all about how to generate different light sources for a pixel art night scene. Still, our town looks somehow empty without moving characters. In this part you will learn how to let lots of characters affected by light walk through the scene. You will also learn how to prepare sprite sheets and normal maps for lighted pixel art characters the easy way. We will then create an Animator override controller you can adapt quickly for all sorts of characters. If you follow my production process, you can easily adapt it for your own lighted pixel art scenes and bring a lot more action and atmosphere into your games. Sounds good? Let's get started! It is important for lighted 2D characters that we need texture images from both sides, the left and the right. Otherwise, something weird happens if your character changes direction. We usually try to do this by flipping the scale. If you do so with a 2D character that uses a material and a normal map, it simply disappears. The problem here is that sprites for characters are usually created with the character facing in just one direction. So for flipping my sprites very quickly, I use a software called ImageMagick with CK at the end. ImageMagick is free and allows me to flip all my sprites directly from the command line. It is important to add ImageMagick to your path environment variable in the Windows system settings, so you can run it from any directory you want. After doing so, I open a command line window in my parent texture folder and run just a one-liner of code in an executable DOS file. This will make ImageMagick process all the subfolders of the current folder and create a flip version of each sprite in no time. I guess this is way faster than any Photoshop approach for this problem. As you might remember from the first part of this tutorial, I use a software called Texture Packer for generating sprite sheets out of my single sprites. Texture Packer allows you to simply drag in all of your folders and create a sprite sheet out of them. Then you download the Texture Packer importer from the asset store into your Unity project. And after exporting the final sprite sheet to your Unity project folder, you can access all the single sprites by their original name. If your free trial of Texture Packer should have expired, there are also free alternatives on the web. Online tools that I found to work quite well are Stitches as well as TopTal. You will find the links below. The free alternatives for generating sprite sheets might not be as convenient as Texture Packer, but, well, they are for free. After you have finished creating your sprite sheets, you will also need a normal map to tell Unity from which direction the light hits your character. Again, as in the first part of this tutorial, I use SpriteIlluminator because I can simply drag in my sprite sheets I generated with Texture Packer, and SpriteIlluminator gives me different options for adapting the normal maps for my characters. As for Texture Packer, you can download a free trial for SpriteIlluminator from the link below. And if your free trial should have expired and you're searching for a free alternative, I have also copied in 2 links to online normal map generators, which do a quite reliable job on this task. Now I will show you how to create a reusable character controller quick and easy. We need 2 animations for walking and idling to the left and 2 animations for the right. So for my first character, I create those animations for the old man from the sprite sheet. I start with the walking animation and drag all the needed sprites into the hierarchy. This lets me save the animation in the project folder and also automatically creates a new animation controller. I now continue to create the additional animations for left and right walking and idling, save them in the animation folder, and drag them onto the first Animator controller I created. I also delete all the additional Animator controllers Unity created when I was dragging the sprites for each of the animations into the hierarchy. After I have dragged all of the 4 animations for the old man into the respective controller, I start to make transitions between the single animations. First, I set the old man walk animation as the default state and then create a transition between walk left and walk right animation in both directions, and also a transition in both directions between walk right and idle right and walk left and idle left. If you now take a look at your scene, you will see that there are still no characters in it, despite we have dragged several animations in there. So what went wrong? Well, in part 1 of this tutorial I created a sorting layer for all the town objects. And currently this sorting layer is in front of our characters. So we still need a layer for the characters too. I create this in the layers menu in the upper right corner and call it characters. Now on the left side I delete all the old man game objects for which we have no animator controller. The character with the animator controller on it I assign to the newly created sorting layer. And now our character appears in the scene. I assign him a walk right sprite in the sprite renderer, which is his default walking state. Give him a more appealing name in the hierarchy window. But still our character is not affected by the scene light. Let's change this. For this we need to create a new material in our project folder. I name my character Matt and assign the character SpriteSheet to its albedo slot and the corresponding normal map to the normal map slot. And also important, I set the material's blend mode to fade. If we drag our material onto the character, you will see that the old man now is affected by the streets and window lights. If you have used Texture Packer and Sprite Illuminator for creating the sprite sheets, you could use this material for all your characters in there. With another solution, you probably will generate a sprite sheet and a normal map for each character separately, and you would need to do this for the materials as well. But this would also be not too much of an effort. The town scene would not be complete if our character is not able to move around. With a simple script we make quick transitions between our character walk and its idle animations. Using an override controller you will be able to let lots of characters move through the town, so you can create a vivid atmosphere. So let's continue by creating a new script called Character Controller. We want to start by letting our old man slowly walk through the town, either to the left or to the right. So let's first declare a start speed variable. And I mentioned before that we cannot simply flip the scale of our character game object to let the old man walk to the left or to the right. But we have created an animation for both sides. So we can change direction by telling our animator to play the right or the left walking animation, depending on the direction our character is facing. For this we need to know if the old man is currently facing to the right or to the left. This is stored in a bool called face_right, which default state is true. We want to give this info to the animator controller so it can play the corresponding animation. Depending on the walking direction of our character, its speed needs to be either positive or negative. This is done in another public variable called speed. Perhaps we also need to modify this variable by another script later. This is the reason why it is public, but I don't want to show it up in the inspector, so I place the keyword hide inspector in brackets on top of it. And the last variable we need by now is our private animator. Next, we assign the start speed to our speed variable in the start method. And we get a reference also to our animator. Inside the update method, we assign a negative start speed to our character if he is not facing to the right, and a positive start speed if he is facing to the right. Under the face right condition, we guarantee a positive start speed result by placing the variable in the math.apps function. This is all necessary because if we're going right, we're moving along positive x values, and if we're going left, we're moving along the negative direction of the x-axis. After the not face right if condition, we set a face_right bool in our animator to the current value of our face_right bool in the script. Last thing we do in the script is to bring motion to our old man by calling a transform.translate function, where a vector3 with our speed variable as an x value is multiplied by time.deltaTime. Now we return to our old man's animator controller and add some parameters. We need our face_right parameter, of course, which is a bool for making the transition between the walk right and walk left animation. And we add two additional parameters, which are triggers, unlike the face_right parameter, which are the parameters idle_right and idle_left. Now, for the transition between walk right and walk left, please make sure that the checkbox has exit time is unchecked, and also that you have unchecked fixed duration, and that the transition duration is 0 for the transitions in both directions. And now we can add under conditions our face_right parameter and set it as a condition of true if we have the transition between walk left to walk right, and we add it as a condition of false if we have a transition in the opposite direction. And also we uncheck the has exit time and fixed duration checkboxes on the transitions between walk right and idle right and walk left and idle left. And for the transition between walk right and idle right, we set as a condition our idle_right trigger, and for the transition between walk left and idle left, our idle_left trigger. We are not setting these parameters yet with our script, but we need them to prevent our character to simply change from walking to idling, even if we don't want him to. And now we've already taken the basic steps to make our animator controller work with our character controller script. To see how our character moves around in the scene, I would now like to drag the main camera beneath the character as a child object. And now we can drag our character controller script onto the old man game object, enter a speed variable of our choice, choose a face right or not face right direction, and hit play. And as you can see, our old man moves through the town And if we check or uncheck the face right condition during play mode, he changes the direction accordingly. Let us finish the character controller by making a simple transition from time to time to our idling animation. This way we give our character behavior a bit more variety. Let's keep things simple by adding a maximum walking time in one direction. If the character has reached a certain percent of this time, he will go idle for a while and then continue to walk. And if max walking time is reached, he will turn around and walk in the opposite direction. To make this happen, we need 4 additional variables in our character controller script. First variable is an integer max runtime, which is the time our character walks before he's turning around. And I add a range slider to this variable so we can comfortably choose the runtime in the inspector. And a second float runtime, which is private and stores the info for how long our character is already walking. Next variable is float change idle with a range slider in the inspector, so we can set the percentage of time after which our character goes idle for a while. And finally, a bool called gone idle, which stores the info if the character has already gone idle during the time he walks, so we do not let him go idle again. Let's build some nice code around these variables. If our character moves, no matter if to the left or to the right, we increase our variable runtime so we know when to go idle or turn around. This is done by an if condition, which checks if the absolute speed value is greater than 0, and below we write, in this case, runtime plus equals time dot delta time. And now comes the most complex line of code, but I will try to explain it as easy as possible. We create an if condition below, and inside this if condition we tell our animator to go idle. Now if we go idle, our speed equals 0 because our character stops while walking. And then we create another if condition inside the first if condition and check if our character is facing right. And in this case, we set the trigger we created earlier in our MyAnimator idle right. And in the else condition, which is valid if our character is not facing right, we set our MyAnimator set trigger idle left accordingly. Now the main condition for this if loop is that our character has reached the change idle percentage we have set in our range slider. And so we write in the main if condition, if runtime is greater than change idle divided by 100 times max runtime, which means that we have exceeded the percentage of runtime after which we want to go idle. And if we are walking either to the left or to the right, so if our mathf dot absolute speed is higher than 0, and if we not already have gone idle, so and exclamation means and not gone idle, then we want to set the trigger either for our idling left or idling right status in the animator. If we add an idle condition to our character, we also have to make sure that our character only moves if he is not idling. And not idling means that his absolute speed is higher 0. So we add this if condition above our transform translate code line. And the last step before we give our character controller a first try is to narrow our if condition for the speed assignment. We only want to assign the start speed to our current speed, no matter in which direction the character faces if he is moving. So we go to our if not face right condition and add an end speed not equal 0. And we do this for the else if face right condition as well. Now we can give our character controller a first try by dragging it on the old man, entering some values for the start speed, the maximum runtime, and the idle chance, and hit play. And we will see that after a while the old man goes idle, but after returning to the walk cycle, he does not move anymore. Our script currently does not know when the transition from idle to walking in the old man's animator has finished. And this is the reason why the old man does not continue moving after going idle. But we can change this by simply adding a behavior to our idle status. A behavior reacts on certain events during the animation. So let's create a new idle behavior C# script for our old man idle right and idle left state in the animator. And for the transition from idle to walk, please make sure that the checkbox has exit time is checked and that all other checkboxes are not. I have chosen an exit time of 3 here for my character. Inside our idle behavior script, we are interested in the onState exit event. This event is fired when idling transition to walking transition has finished. On this event, we want our character controller to know that the idle state is over and that we want the game object to be moved on. So let's get a reference to the character controller script here by declaring the variable and getting the component from our animator in the onState exit function. Now we can set the goneIdle variable in our character controller to true so that our character continues walking. Next, we change to the character controller script because we need to add the goneIdle condition to our if face right and speed condition now. We can simply put our speed and goneIdle variables into brackets after the face right, not face right statement in this condition. And next, some small adjustments to make our code look even cleaner. The variable speed does not to be public, so let's change this to private. And the variable goneIdle needs to be public, but I don't want to show it in the inspector, so let's place an hide in inspector above this variable. And I put the face right check together with a line for the animator into a void function called check walk position. This function will be called on every update call before the transform.translate method. Switching back to Unity, our character controller now looks neat and clean. If we give it a try in play mode, our old man now starts to walk, goes idle after a while, and then starts to walk again. And to give the controller a finishing touch, we let the old man turn around after maximum runtime and walk the same distance in the opposite direction. This we can do by inserting a last if condition before we call the check walk position function. So for this action, let's write in an if condition runtime greater than max runtime, then face right is getting its opposite value. We set runtime to 0 and gone idle to false. During play mode, you can now see the old man walking, idling, turning around, and this action repeating in an endless loop. The cool thing now is that we can use the old man's Animator controller as a simple blueprint for all kinds of townfolk. This can easily be done with a so-called override controller. I create one in my animation folder, then drag on the old man controller, and for each animation in the original controller, the override takes in an animation with which we can, of course, override it. In just 2 minutes, I have created the required animations for my woman character from the SpriteSheet. I gave the woman's idling and walking animation to each of the directions left and right similar names like those of the old man. So I know at first sight which override animation corresponds to the original one. Now I place them in the 4 slots and rename the override controller to woman controller. Then I duplicate the old man's game object in the hierarchy and replace the old man controller with a woman controller. And I of course also change the sprite to one of my walking woman. And I give the sprite renderer a different order and layer to the old man so the sprites don't overlap. I adapt my parameters for the character controller of the woman to give it an individual touch and make it different from the old man movements. And within no time we have a second character created for our town. And by using a shared SpriteSheet, we even do not need to create a new material for the character to be affected by light. You can go on like this and create all sorts of different characters for your night scenes in very few time. Wow, this was by far my longest tutorial, but I learned so much cool stuff by making it, and I hope so did you. I have this strong feeling that this channel is going somewhere, with the great support I received from you guys so far. So please make me even more happy with your subscriptions and thumbs up. And I will be back soon with new stuff for you.